Fire. It can warm us, cook our food, and light our way. But fire can also be a destructive force. For centuries, humans have grappled with this duality, seeking ways to harness fire's power while mitigating its risks. This struggle led to the development of fire systems. Early fire safety methods were rudimentary. People formed bucket brigades to douse flames. Buildings were spaced apart to prevent fire spread. These methods, though simple, represented the earliest attempts at fire protection. The invention of the hand-pumped fire engine in the 17th century marked a significant leap forward. These engines, though labor-intensive, allowed for more effective firefighting. The Industrial Revolution brought further advancements, including steam-powered fire pumps and the use of cast iron in building construction. The 20th century witnessed a revolution in fire safety. The invention of automatic sprinklers, sophisticated alarm systems, and portable fire extinguishers transformed fire protection. These advancements, coupled with stringent fire codes and public awareness campaigns, significantly reduced fire-related deaths and property damage. Imagine this. It's the middle of the night, a fire erupts in your home. You're sound asleep, unaware of the danger. This is where fire alarm systems come in. They are designed to detect fires in their early stages and alert occupants, giving them precious time to escape. Early fire alarm systems were basic. They often relied on heat detectors, which triggered an alarm when temperatures reached a certain threshold. These systems, though effective, had limitations. They were prone to false alarms and sometimes reacted too slowly. Modern fire alarm systems are far more sophisticated. They utilize a variety of sensors including smoke detectors, heat detectors, and carbon monoxide detectors. These sensors are strategically placed throughout buildings to provide comprehensive coverage. When a sensor detects a fire, it sends a signal to the fire alarm control panel. This panel acts as the brain of the system. It activates alarms, notifying occupants of the danger. Simultaneously, the panel can send a signal to the fire department, ensuring a swift response. Sprinkler systems are a cornerstone of modern fire protection. These systems, often unseen in ceilings and walls, stand ready to unleash a torrent of water at the first sign of fire. They are designed to suppress or extinguish fires, minimizing damage and saving lives. Sprinkler systems consist of a network of pipes, sprinkler heads, and a water supply. Each sprinkler head is equipped with a heat-sensitive element. When a fire ignites, the heat rises and activates the sprinkler head nearest the flames. Contrary to popular belief, sprinkler systems are not triggered by smoke. This ensures that they activate only when there's an actual fire, preventing accidental discharges. When a sprinkler head is activated, it releases a jet of water, targeting the source of the fire. Sprinkler systems are designed to control fires, not necessarily extinguish them completely. Their primary goal is to suppress the fire, preventing it from spreading and giving occupants time to evacuate and firefighters time to arrive. Not all fires are created equal. Some fires, like those involving flammable liquids or electrical equipment, require specialized suppression methods. This is where fire suppression systems come in. These systems are designed to extinguish or control fires using agents other than water. One common type of fire suppression system uses clean agents. These agents are gaseous substances that are electrically non-conductive and leave no residue upon evaporation. They work by interrupting the chemical reaction that sustains a fire. Clean agent systems are often used in areas where water damage would be catastrophic, such as data centers and server rooms. Another type of fire suppression system uses foam. Foam systems are particularly effective against flammable liquid fires. They work by smothering the fire, cutting off its oxygen supply. Foam systems are commonly found in aircraft hangars, oil refineries, and other facilities where flammable liquids are stored or processed. Fire suppression systems, like sprinkler systems, are connected to a fire alarm system. When a fire is detected, the alarm system triggers the appropriate suppression system, releasing the extinguishing agent. Before firefighters arrive with their hoses and ladders, there's often a critical window of opportunity to extinguish a small fire before it becomes a raging inferno. That's where fire extinguishers come into play. These portable devices are essential tools in fire safety. Fire extinguishers aren't all created equal. They come in different types, each designed to combat specific classes of fires. Understanding these classifications is crucial for using the right extinguisher effectively. Class A extinguishers are used for ordinary combustibles, such as wood, paper, and cloth. They typically use water or a dry chemical to extinguish the fire. Class B extinguishers are used for flammable liquids, such as gasoline, oil, and paint. They use foam, carbon dioxide, or a dry chemical to extinguish the fire. Class C extinguishers are used for electrical fires, such as those involving wiring, appliances, and electronics. They use a non-conductive extinguishing agent, such as carbon dioxide or a dry chemical. Using a fire extinguisher is relatively straightforward, but it's essential to know the proper steps. Remember the acronym PASS, pull, aim, squeeze, sweep. Fire detection technology has come a long way from the early days of simple heat detectors. Today's systems are more sophisticated, reliable, and capable of detecting a wider range of fire conditions. Smoke detectors, for instance, are now available in two main types: ionization and photoelectric. Ionization detectors are better at detecting fast-flaming fires, while photoelectric detectors are more sensitive to smoldering fires. Many homes and buildings now utilize dual sensor detectors, which combine both technologies for enhanced protection. Heat detectors, too, have evolved. Modern heat detectors are more accurate and less prone to false alarms. They are often used in areas where smoke detectors might not be suitable, such as kitchens and garages. Advanced fire detection systems go beyond traditional smoke and heat detectors. They may incorporate technologies like aspirating smoke detectors, which draw air samples into a detection chamber for analysis. These systems are highly sensitive and can detect fires in their incipient stages. The unsung heroes: fire safety codes and regulations. Behind the scenes of every fire safety system are a set of stringent codes and regulations. These regulations, often developed and enforced by local and national governments, dictate the design, installation, and maintenance of fire protection systems. Fire codes cover a wide range of aspects, from the materials used in building construction to the number and placement of fire exits. They also specify the types of fire detection and suppression systems required for different occupancies. Building codes often incorporate fire safety standards, ensuring that structures are designed and built to resist fire and facilitate safe evacuation. These codes may address issues such as fire-resistant walls, fire-rated doors, and sprinkler system requirements. Fire safety codes are constantly evolving to keep pace with new technologies, construction practices, and fire hazards. Regular inspections and testing of fire protection systems are essential to ensure their ongoing compliance with these codes. Real-life heroes: stories of fire systems in action. The importance of fire systems is best illustrated through real-life stories of their effectiveness. These stories remind us of the critical role these systems play in our safety. Consider a family sound asleep in their home. A fire breaks out, but their smoke detectors sound the alarm, rousing them from sleep. They evacuate safely, and the fire department arrives to extinguish the blaze. Smoke detectors played a pivotal role in preventing a tragedy. In another instance, a fire erupts in a high-rise office building. The building's sprinkler system activates, containing the fire and preventing it from spreading. This quick response allows safe evacuation and minimizes fire damage. These stories underscore the importance of fire systems.